Good afternoon, and thank you. I will be short. I will try to be short, actually. My presentation is about the personalization and sequencing of the learning objects in a serious game. It's not about the design aspect of a serious game, but about the personalization of learning content in a serious game. For this, I propose a generator of adaptive learning scenarios, and I will present the studies, design and implementation, and evaluation in the context of the project. I will start by presenting my system. I will start with what motivated the research and the application on which I am working, and the objective of the research, my contributions that I have contributed in order to validate the predictions that I have proposed. I will finish by some conclusion perspectives. This research is based on two major domains. The first one is the adaptive learning system. These systems contain course sequencers, course generators, adaptive navigators that are used to sequence the set of learning activities according to a learner based on its physical cognitive competencies. For my research, I am more interested about the adaptation provided to learners who are in situation of cognitive or physical handicap. The second domain is CS games. CS games are being. I tried to use learning. I tried to merge these two systems and provide a personalized learning about CS games. During my research, I worked on the project is called CLES. CLES is an abbreviation for Cognitive Linguistic Element Stimulation. It's a project funded by the French government. The objective behind this project is to propose a CS game environment for the education and rehabilitation of children who are in a situation of a cognitive handicap. So they will create a CS game environment, and they will propose activities that can help the rehabilitation of cognitively handicapped children. They target some major cognitive domains like perception, memory, visual spatial movement, written and oral language, and logical reasoning, and diverse competencies. For this domain, they have proposed 9 mini games. Mini games are learning objects, learning resources, and learning or pedagogical resources that are used to target a very specific cognitive domain. For example, their perception is further divided into perception, auditive perception, and memory is also divided into short-term memory, long-term memory, or working memory. And for each type of subdomain, they are related many games related to it. In total, there are about 91 games, and there are about 7,000 users. And this project is available online. So the problem faced by the conceptors is to propose a manual sequence of activities in the CS game so that they can target a particular cognitive disability in a person. For example, if a person who has some problem memorizing something, they will start by first checking whether he can perceive things correctly. If you do not have a problem perception, they will check that he can attend he do not have attention deficit. So if all things are correct, then they will propose the size of memory. This is the environment proposed by CLES. You can now take there is a main character, and he is situated and he is placed in mansion. This mansion consists of many rooms. Each room contains many different interactive objects, and the objective of this game is very simple. The characters have to interact with different objects. Behind these objects, there are some serious games, mini games. These mini games have to be solved by the learner or by the user to further progress in the game. Here I present an example of such a mini game. These are the learning resources of this mini game. For example, this is called identify intermediate objects. It targets the visual perception of a learner. The objective is to identify the models, elements that are intermixed in a model. For example, here we have a rectangle, a triangle, a square, triangle, and a hexagon. and the user has identified which object is present in among the responses that are given. And these games can be parameterized, can be adopted according to a certain learner by the picking of certain parameters. For example, we can we can increase the complexity of the model by introducing more elements. We can change the type of elements from geometric objects to letters or alphabets, or the number of responses that are given to the user, or the time that is given to the user to in this concept, the main objective is to propose a system that is able to generate adaptive learning scenarios. These learning scenarios are sequence of learning activities that are selected keeping in mind the pedagogical or learning objective of a learner. And they have to keep certain properties. First and foremost is user profile. The user profile contains the competencies of a user, his skills, his cognitive and physical abilities, his preferences, etc. And second is that this learning scenario should be able to be used in a CS game environment. So it has to keep into account also the CS game specificities or the CS game design considerations. Number three, we use the interaction cases of a learner which is left behind by the system while he or she is interacting with the system as knowledge source to adopt the scenario according to his or her performance. And the characteristics that are desirable by a system is to, number one, that it has to be generic, that it can be used with multiple pedagogical domains and with a variety of adaptive with a variety of CS game. And the second is scalability, means that the user has to time to time adopt it or modify or update its knowledge model so that it remains accurate according to the learners who are using the system. Keeping this the in mind, there are such questions that are put forward and were answered. And the first one is to which technology to represent and how to represent them in order to achieve objectives and the characteristics of the system. So we identified that in order to stay fidel with both the pedagogical domain and the CS domain, we have to model the domain concepts, the pedagogical resources that are used to this concept, the gaming elements, and the learner profile. And we have arranged a multi-layered architecture that I will present to you in a short bit. Once this knowledge is identified, the next step is to use this knowledge and to generate adaptive learning scenarios. These scenarios must look on the learner profile and learner user's profile and the CS game specificity. And the goal is to find a way to exploit the knowledge left behind by the user in a way that can help the system to be more accurate according to a particular learner. For this, we use the cases to update the scenario as the user interacts with the system, that is pedagogical scenario, and the updation of user profile according to performance and the domain knowledge if necessary. And last, we test our models by creating a prototype and conducting an experiment with the next of project related to some country. This is the general knowledge architecture of my system. It is divided into three layers. The first contains the domain concept, the concept that are related to a particular pedagogical domain. The domain concepts are arranged in a type of a graph where the nodes represent the concepts and the relations and the edges are the relation between those concepts. These concepts, the relation between concepts are typed. That means there are many types of pedagogical relations. For example, prerequisites, head pass, each concept is related to one or more pedagogical resources according to the model, and vice versa, pedagogical resource can be related to one or more domain concepts. And then we have the gaming source layer where we define the element the CS game elements and make a relation with them with the pedagogical resources so that a pedagogical resource can be used in a CS game environment. This is a representation of the domain of the knowledge system. On the top you can see the domain concepts. This is the knowledge related to the project CLES. In the Excel, it's very complex and it's a very dense graph. So I just showed a portion of this graph. You can see there are different concepts which are related to each other via different relations. Some are prerequisite relation and some are has-part relation. In the second layer, there are the pedagogical resources. These are the mini games that I've shown you. Each concept has one or more pedagogical resources. In the third layer, we have the CS game elements. These CS game elements represent actual objects in the CS gaming environment. So the idea is to attach these resources behind these CS game elements so that can interact with them and play with them as necessary. Some modeling of the domain concept. The domain concept is a graph, as I said, with the concepts and between those concepts. A concept can be identified when identifying some meta properties, can be identified by source relation, the type of relation, and the target concepts. In the context of project, we implemented some 4 kinds of relation, but we can have many kinds of relations. Can be identified by an identifier. Its role it plays. A particular resource can be of type example, of definition, a mini game, etc. So it can be of many types. And there can be many types of roles that can play in a particular scenario, and the concept with which it is related and some meta properties. Same goes with the CS game model, where I can identify a particular resource with which it is related. It's type in the CS game, and the role is it plays and some meta characteristics of the system. The second composition is the model of a scenario generator. The first step is that, as you can see on the upper right-hand corner, is the definition of the user profile. User profile is an overlay of the domain model. The user profile contains all the competencies of the user and his preferences, his skills, all the meta information about the user. The user profile is defined in either the user or either the learner or the expert define the pedagogical goals. According to these pedagogical goals, a series of concepts are selected from the domain graph. These concepts are necessary to attain the pedagogical objective for the learner. The concept selection is then according to the type of relation that are placed in the concept graph. So for each type of relation, we have defined a selection strategy which works differently for different types of relations. Once the concepts are selected, then for each concept, a list of pedagogical resources are selected. These resources are selected according to the presentation model on the right hand side. This presentation model defines which resources should be selected and how they should be arranged. For example, we can start with an introduction, then followed by an example, exercise, or theorem, etc. Once the pedagogical resources are selected, then we also have the possibility to adopt for the adopter. For example, I have shown you in the mini game that there are many parameters, and this can be made difficult or easier according to the competence of the user. So once the resources are selected, they will further adopted according to the user. Once the scenario is generated, these pedagogical resources will be associated with the gaming elements, and once they are associated, they will be sent to the serious game. The user will interact with the serious game, and as a result of this interaction, some learner classes will be generated. These classes are modeled and formalized and are stored in the user profile, where they will be used as knowledge to adopt the pedagogical scenario, and on the other hand, to update the user profile and to update the domain knowledge if it's necessary. To test all our theoretical models and put theory into practice, we implemented all these models into a prototype. This prototype is available online, and we conducted an evaluation in the context of Project CLES to verify whether the concept selection strategies are good or the knowledge represented by the Project CLES is fine, or it needs some tweaking or some modifications. The evaluation principle is simple. It's based on comparative studies. We will define some learning profiles and some learning objectives. Then for the same, we will ask the expert to create a pedagogical scenario for the same input. And for the same, we will put the same profile and the pedagogical objective in our system and generate a number of scenarios. Then we will ask the expert to compare these two scenarios and tell us his evaluation generated by the system. To help us in the implementation, we follow the evaluation protocol. This protocol is necessary to guide us through the experimentation process and if something goes wrong, then to help us identify the problem. It starts with something like this. As I told you before, we will have a collection of learner profiles, which will be ideally diverse and some pedagogical objectives and defined by experts. And for each kind of profile and pedagogical objective, the expert will generate some scenarios, and some will create some scenarios. These two scenarios will be compared by the experts. If the expert is satisfied, then we will test on the third step, we will test the scenario with real learners. And by analyzing their classes, we will try to find out whether these scenarios are good enough for them or not. If they are good, then we will stop. If they are not, treat them as the same case if the expert is not satisfied. If the expert is not satisfied, then we have two possibilities. Either the concept selection strategy of the scenario generator is wrong, so there is something wrong with it, so we have to tweak it and correct it so that it generates relevant scenarios, or there is some problem in the knowledge entry of the system. It means that the expert has not correctly related to concepts, or there is some links missing or things like that. This evaluation was conducted, an experiment was conducted with a domain expert. This domain expert was a speech therapist and has an experience of more than 20 years. So he provided us with some profiles and learning objectives which he feels are pretty much accurate. So he conducted an experiment. The experiment contained 40 concepts. There were 40 concepts, 44 relations between those concepts. There were about 91 mini-games, and we created some 18 profiles. These profiles were divided according to age, because they initialize a certain profile according to his or her age. So in total we had 18 profiles, and we created the scenarios and asked the expert to, after the experiment, we asked the expert to compare these two scenarios. This is the type of system that I have implemented. On the left hand side, you can see the list of. We have a list of learners. On the center, we have some pedagogical objectives. This is a view sheet as shown to the expert. The learner, the expert selects a learner. He selects the pedagogical objectives for the learner. For example, here it shows that perception should be taught 100% at the 100 maximum level, and then we generate a scenario. The scenario is generated in 3 steps. Number 1 is the number of concepts that are selected. On the first layer, we can see all the concepts with the concept in the white background are not selected, but the concepts in the violet background are selected to teach to the learner. And for each selected concept, we have a number of pedagogical resources that are selected, and these resources are associated with certain game elements, which are then forwarded to the gaming engine, who renders these pedagogical resources into playing objects. This experiment was videotaped and annotated by using a video annotation tool. After the analysis of this tool, we discovered some interesting a new concept was added, which the expert hadn't added previously. So he felt the need to add another. 5 new relations were added between the concepts that were previously related. And the one thing we were missing, that when the expert was assigning the difficulty level of a certain mini game, he was taking into account the learner profile and the objective set of the system, while we were only taking into account the learner profile. So once we created it in our algorithms, and the expert was satisfied. So in conclusion, we conducted this experimentation with only one expert, so we would like to do it with some more experts, and we would also like to perform to model some other pedagogical domains with some other serious teams, so that we can further verify the claim that our system is a bit generic from pedagogical point of view. Some experiments has been conducted with some real-world users to identify where the sequencing of some good sequencing of learning objects actually provides some learning gains. So it's a very traditional classical evaluation where the peers are tested and afterwards the course is conducted. What we like to do is to use the classes to obtain domain knowledge as it seems necessary. So that's it.